vinyl mastering for electronic music, and why does it matter? Well, electronic music usually has long tracks with a lot of low end and with a lot of stereo with information. And these three elements don't like each other when it comes to pressing music on a record. Luckily for us, today we have a beautiful tool called Simulathe from Tokyo Records that allows us to see, before sending the music to the pressing plant, what problems might arise. By any means, this is not me thinking that a plugin will replace a cutting engineer, and in fact every cutting plant will work with a cutting engineer before getting the music on the records. But the idea is, before sending the music to the plant, that you can check what you can do in the session in order to mitigate the risks and to conform as best as possible the digital mastered versions for pressing on a record. And maybe you can do some little tweaks here and there that don't need to be applied on the whole track, that can help actually the music to be fitted for the support. Before anything, I'd like to make a quick introduction about the pressing plant and the communication with the pressing plant. You might argue before we start that you already sent whatever digital mastered version to a pressing plant and that the vinyl came out okay. And you're right. Why? Because between the file you are sending and the file that gets printed on the vinyl, there is a cutting engineer working. And the work of the cutting engineer is actually to make sure that the audio file does comply to the needs and to the technicalities of the vinyl support. But chances are that while doing so, there will be quite a lot of alterations from the digital mastered version and the vinyl mastered file. And this is why, before doing anything, communication with the pressing plant is mandatory, because if you spend time to mix properly your track, to having it properly mastered, I would say digitally mastered, and then put in a box that makes it vinyl compatible, making some trade-offs. And if you send that to pressing plant without telling them, chances are that maybe some lazy cutting engineer or some pressing plants with a lot of demand will just apply generic filters and processings in order to make your music comply to the support. Usually what happens is it's a roll-off of the lows, an elliptical filter, which is a filter cutting out the lows on the side part of the signal, so the mid side remains intact and the sides are removed depending on the pressing plant between 100, 120 or 150 Hertz. They will most of the time use de-essers or de-essers also on the side parts to control the transients on the sides, because this is something the vinyl doesn't like. And if you send a very squashed and very loud record, they will most definitely play it a lot quieter in order for it to be printable on a vinyl. So yes, whatever the digital file you will send to them, they will make it comply, but if you do things properly, they will not need to do it, and you will have a much better translation from the digital version and an overall better sounding masters. But if you do it without telling them, they might even add some process to the process that you already did. This is why first things first, communication with the pressing plant is super important. Maybe even ask them for some back and forth. You can tell them, I made a master that should be vinyl compatible. If you see some portion where it makes it not printable, please let me know, and then you could also make the revisions yourself. Ensuring a proper communication and the best possible translation from the source to the vinyl is the key for success here. Let's talk a bit about how does the music translate through the groove, right? So on the vinyl is a groove in which you have lateral and vertical movement, right? The needle can move from front to back, from my listening position, from front to back and from top to bottom. So if you have something that is very loud, moving a lot, and that you have a lot of music to print on one side, at some point the two grooves, let's do it like that in vertical version. Okay, this is the record. You have several grooves. The two grooves will start to touch each other and to collide. And this is the most problematic issue, is the skipping of a record, right? So the trade-offs are low end versus overall volume versus playtime. And this is really the first problematic triangle. So if you have 2 minutes to print on a record or 20 minutes, you will have a lot less space with the 20 minutes. And so you have less choices about low end and loudness. That's the first really problematic triangle. Let's talk about then the playback speed. Record can be put at 40, 45 rotations per minute or 33.1 third. At 45 rotations per minute, you can get ideal 4 or 5 minutes without too many constraints, 12 minutes maximum. At 33.1 third, the maximum music playback you can put on the record is around 20-22 minutes. So you can put more music. But the trade-off is that you have a tighter bass with 45 rotations per minute. You have something louder, and of course you have a better high frequency representation, because as the record spins faster, the needle can move faster. For the cutter, for the needle cutting the record fast, first, if you have too much high frequency content, you can burn the cutter. There are trade-offs, and this is the first really important thing to understand is vinyl will always have trade-offs. There's no magic. Digital, you can push things, you can squeeze things. The only magic you can have is sometimes reduce the inner circle radius on a vinyl. But this is something you have, again, to talk with a pressing plant. They can reduce a little bit the inner circle to gain a bit more space on the record. Not all pressing plants do it. Overall, as we said, you don't want too much low end. You especially don't want any low end in the side signals, because this will make the needle skip a lot. But if you use elliptical filters, you can fix the stereo width, but then you can induce stereo image changes, and also you need to control the highs. If you do this in a lazy way, you just put filters, low highs, and this is what lazy cutting engineers will do. This is something we don't want. It will affect a lot the audio signal. So instead of that, what we want to do is check the master with something like Simulathe from TDR, and when we see that at some moments in the audio file there are some problems that arise, then we might fix this with automations. Good example, do you prefer an audio track with a low cut filter all the time, or just one happening at one moment? A good example is the last master I did for vinyl. There was in the break a rise up with white noise, but they added some kind of stereo imager tool to make this noise wider. White noise wider means low end, high end, everything all over the place, right? This was making the measurement in Simulathe crazy. Is it better to put filters through the whole track, or to just automate that moment to reduce a bit the width of this rise up at that moment while keeping the integrity of the whole track? You get my point, right? It's better to adjust at that moment. And this is why you can do better work if you do a specific master for vinyl up front and you spend time checking things and do it properly. So we spoke about length, we spoke about high frequency, low frequency, stereo width. Now that we tackled all those in a theoretical approach, let's dive into Simulathe and let's see how it's working, what it shows us, and how we can use it to master really properly. And of course, tell the pressing plant, I checked this all in Simulathe. It doesn't mean it's safe for everything, because every cutting machine has its own specificities, has all different little differences in the signal it can process. But overall, if your master is like Simulathe safe, you can let them know, and they know that chances are that many things are already okay, and maybe the pressing plant will just need to lower the level of 0.5 dB of the overall output level, and the thing will be totally fine without any extra processing. Communication, explaining what you did, explaining how you tried to do the best you could without taking their job. Don't pretend you know better than them. They know their job. At this point, I'd like to express my sincere gratitude to Fabien from Tokyo Down. He took the time to watch this whole video before me releasing it, and gave me some notes and some fine-tunings on things I said. So yeah, let's dive into the juicy stuff. Okay, so here we are inside the project. I started by opening up the master project of the digital files. These are the files that have been agreed on by the artists. And first thing I'm doing is actually to remove any end limiter, because I don't want the signal to be squashed into a limited. I'm placing the tracks in the exact playing order. I'm trimming any remaining tails or any silence at the beginning that are unnecessary, because, well, time is a very important aspect of the cost of pressing a record. So you want absolutely to avoid any unnecessary tails or silence, like 5 seconds or 10 seconds of silence at the end of a track. And you want to leave like 1 to 2 seconds of silence between the tracks to have a proper visual cue where to place the needle on the record, and you want this to feel also natural, so you can just play it back and listen how it feels, how the sequence is feeling, right? So next thing you also want to do is to match the perceived loudness of the different tracks that are going to be pressed on one side. You want one side to feel coherent and to feel even through the whole record. And to do so, you can use different tools. What I like to do is you remove the limiter, you put a utility, and I'm playing this back. On my master, I use the trusty metric AB from Adapter, which is actually showing a lot of different informations about loudness, the integrated levels, short-term, momentary, and also the RMS. We don't mind about the true peaks. I would say we don't mind either about the short-term LUFs, but what matters is, I would say, a mix, a blend between the integrated LUFs, which are the LUFs through the whole track. It's the feeling of the loudness of the whole track, taking into account some silences, some breaks. If you want to know more about the LUFs and the calculation of LUFs, I have a video about that. And the momentary is on a shorter period of time. The highest part of, let's say, the drops and the part where you want a feeling, a measure of how the louder part of the track are sounding. And because we are here mastering electronic music, dance music, this is a key for me, a key indicator. So I would use both the momentary and the integrated to find a kind of balance where everything feels more or less even. Of course, I'm going to play it back and by ear adjust things. And the way to balance things is to look at the quietest track and to lower the levels of the loudest tracks to match the quietest. You want headroom, you don't want any peaks, you don't want to hit close to that 0 decibel true peak. Actually, you will even be more like below 3, but whatever, that's not really important for the moment. You will just want to adjust the loudness and gain some headroom, so bringing things down. This is what I did, and once I did that, I just rendered all those tracks and put them back below here, and this is my simulate channel, right? Simulate. This is where I'm going to load simulate. Actually, it's already there. Let's start again here. Simulate, you have the choice. You can say just one side, or you can call a second side, say side A and side B, which has the two sides of a record. If you are making a multi-record, you can just add as many as you want, right? Let's delete that for the moment. Actually, you know what? Let's delete even the A and let's start. Okay, so here we are. We start with side A. We are playhead at 0. And we want to set up this at 0. So play it at 0, I say set, and at 0 I have the marker of the beginning of that side. I go to my last track, totally at the end, place a marker here again, and here I can set the marker of the last part. And you see it's pointing here, and I can say, okay, now I have the total length of the music that I want to print on that record. This is already a kind of warning sign, a red flag. 23 minutes is long, we'll have issues here, but let's keep it that for the moment, right? Once you have that, you can just render a freeze so you can spare time. You could play through the whole music and then it's gonna create this three-dimensional map of the record with the groove movement and the depth. The music has to play through Simulate for it to create that map, but if you want to spare some time, you can freeze the track and then it's doing this offline, and you see this is a progress bar. We're gonna go much faster than if we were playing this music from start to end. Okay, track is frozen. Now I can unfreeze it. Let's open Simulate and let's first look at this usage percentage. You definitely don't want to go above 85%, and it's a good practice to stay below 75, even 70%. As you'll see, this usage is also determined by the loudness of the groove I want to put on the record. If I reduce the loudness, I gain some usage. If I increase the loudness, I increase the usage, because the groove has to be wider and deeper in order to be louder, right? So what are good targets and what are the interesting information we can take out of those disk stats? So Excursion describes the lateral movement of the groove and is representing the amplitude of the signal. So you can control Excursion by adjusting the gain, the level of the signal, and of course, because low frequencies tend to induce the biggest swings. By rolling off the lows, you will reduce the lateral movement of the groove. No movement equals silence. You double the loudness, you double the distance of the movement on the groove. We see that we here have some issues, but maybe, yeah, the gain is here crazy. Let's get back to some normal values. I said like 80, 85, but wait. Let's get back to 33, something like 70%. Let's go back. Okay, so this we see that for the excursion, it's totally fine. You want to stay below 40 micrometers. If you go above, this is where skipping and problems can arise. With the cutting stylus is a 90 degrees stylus, meaning that actually the deeper you go, the wider you become, right? You have a direct link between depth and width of the stylus. The vertical movement will define the stereo image. And of course, if you have too wide stereo information, you create a jumpy needle. And this you want to stay below 100 micrometers for that one. We are at maximum 73, so this is also very nice. We're going to use maybe other examples to see how we can fix things. Velocity, this is how fast the cutter is moving. Here we fix this at 40 centimeters per second, and this is a good value for most of the cutters to avoid them burning or being damaged. So this is a great thing, and we see that here this is very, very fine. We don't have so much like high frequency transients and side information. And length, this is the distance between the two grooves, 12 micrometers. Some cutters go down up till 5. You can say that if you place 12 as a baseline, this is a safety value. And so actually we see that with these settings, pressing this with a gain of -4 and being at 70% of usage, we are kind of great. Kind of good for everything. If I crank it up more, just for the sake of the exercise, like above 80%, excursion is still okay. We have a very few elements that have a little of excursion here. The rate, but that's not that big deal. With also we have a bit of width that goes above. We stay still below 120. 120 is really the upper maximum, but I wouldn't advise going that much. Velocity, we are also a bit above, so this is not great. So we see that it's starting to slowly fall apart, right? So the gain is really the first really important aspect of how you press to vinyl. And of course, it's always better to play safe. And the cutting plant can always increase the level till the point that it's not fitting anymore. Let's have a brief chat about DC offset. Well, in the digital world, DC offset doesn't matter that much. You lose a bit of headroom for speakers. You create a bit of asymmetry in the excursion of the woofer, but it's not that bad. But for vinyl, it's disastrous because the cutter works by tracking velocity, and DC is technically infinite excursion. So you really need to get rid of DC offset before hitting the cutter. You can use either low cut filters because DC offset is 0 Hertz. It's current that is not modulating through time. So the lower frequency you are cutting, you are removing in DC offset, or you could use DC removers filters. But this is something that you have to be really, really cautious about. You can't press a record with some DC offset. RIAA filters. This is something very important that we need to talk about. RIAA stands for Recording Industry Association of America, and it's a standard that has been used since 1953. What are those filters and why are they used? We've already seen that there is a problem with low-end and records because low-end means excursion and also takes space. So in order to be able to print longer tracks on a record, we wanted to get rid of that low end to minimize its impact for the pressing plant. The RIAA filters is a filter that will start to reduce lows before printing the music on the record. And of course, in any phono preamp, you have the opposite filter that creates the de-emphasis. So we have a pre-emphasis to print it and we have a de-emphasis to listen to it. Another aspect of the vinyl record is something we didn't talk yet about, is surface noise. Surface noise is basically the noise you have when you put the needle on a groove at the end of the record or at the beginning of the record. You hear this kind of hiss. This hiss is more present in the higher frequency. So we press more highs on the record and then we listen to the music with lesser highs, means also lesser surface noise, right? So how does this filter work? It starts to shift a bit the sound around 500 Hertz, and at 20 kilohertz we reach up to like 20 dBs of gain. This is quite heavy filtering. If you want to listen to it, you can just plug your turntable on a line input of any mixer or amplifier. You'll have to crank up the level quite a lot. Or you can check in Simulate. Here in Simulate, you have to switch the monitoring, not the input, not the feedback, but you switch to the pickup. You have the defects that you can turn on and off. And in the defects, you can listen to the RIAA encoding or not. So the great thing about Simulate is that it's already loaded with the RIAA curve. So everything you see inside Simulate has this curve being applied to. Here is a graph of a RIAA filter. It might seem like it's only starting to affect sound at 1 kHz, but this is just for a reference standpoint. You get the idea of the curve. That's important. If it were only for the low end, engineers could have used just a high pass filter. The brilliance of RIAA is that it balances both the physics, the psychoacoustics, and the practicality in one elegant inverse paired EQ. Pre-emphasized, de-emphasized. So now we talked about this filter, you understand also why high frequency content is so important to take care of when pressing to vinyl. Because of that tremendous boost, the cutter sees crazy high frequency. So the tiny little sizzle on a hi-hat or a bit of white noise is actually immensely more present on the record itself. So you need to properly control those high frequencies, and also of course the transients that are poking at that frequency range. Okay, so let's have a look here at another project. Don't worry, the audio is not squashed. I just zoomed in a lot to see the proper tails at the end of the tracks and to place the silence. For copyright issues, I will not play the audio for this one. So let's load TDR. This has already been set up, track B with input and output moments. And if you look at the disk stats, we will see some things here. So Excursion is fine, so we don't have too much stereo information on the low. We see that we have some tight issues here happening. Okay, so we'll have to control the whiz. Velocity seems fine, and land is just on the hot but still okay side because the minimum is 12.5 micrometers. So we have some hot moments, but it's still kind of okay. This is the kind of things that you can still leave to the cutting engineer. So about the Excursion, there's a little thing I want to still address, because as I said, Excursion is the low-end stereo with information. And of course, TDR has some processors that you can activate to fix things. But I want to show you a little trick about the elliptical filter, how to see if it's linear phase or not, and what happens if it's not linear phase 1. So what I did is operator signal playing a square wave at 25 Hz and sending this to an audio channel with some filters in there, right? So playing one note, you see it's playing. I have signal just on the left. What happens if I turn on Simulate with the elliptical filter at 100 Hz? Look, now I have signal on the right. This is because filters induce phase rotation, and because the sum and the difference with the MS processing are making phase differences that we sum, hence shiftings in the stereo width. You can check more about Basslane Pro video. And so talking about Basslane, and this was kind of a disappointment, but yet it's understandable. Basslane sub-frequency cutting the sides at 100 Hz. I see the same problem here as well. So I don't mean this in a way to say that Simulate is a bad tool, just that the linear phase filters are not totally linear. Why I'm saying this? Because if I do the same cut in Pro Q4 at linear phase mode, whatever the type, this problem isn't there anymore. Even if I go to higher range filter, so you can get away with more low-end cut without affecting the stereo image. Be careful, because linear phase filters also induce pre-ringing, and I guess this is why both Simulate and Basslane Pro didn't put it so far. I think it's a way to get kind of okay phase relationship. It's not totally linear, but it's not inducing too much pre-ringing, because otherwise you will smear up all the transients and all the low-end tightness information. So this is something you don't want. So always be careful with those elliptical filters, right? With a very short attack like this, we could record that to another audio track. This linear Pro Q, And let's call in as a comparison Basslane. But you see here, the transients are very sharp, while with the linear phase, you have this lead in, which is pre-ringing, and it's smearing the transients. So there is no fix for all. I'm not saying that you should never use linear filters. I'm not saying that you should always use minimal phase filters. You have to be aware of what's happening here, okay? Linear phase preserves totally the stereo image integrity, but is smearing the transients. And one might argue that shifting things a bit from left to right when it comes to stereo information below 150 Hertz doesn't have any importance because we don't have any stereo location below 150 Hertz. So all things considered, why did I say that I love Basslane Pro is because once you remove side informations, you can also just remove energy because it's information on the side that is there. And so what I like to do is have recovery. And so you can actually feed back energy from the sides in the center to have the same loudness, right? When it comes to low-end control, instead of just throwing an elliptical filter, I'd rather come back to Basslane and do those little adjustments into Basslane Pro. That's just a matter of choice. You can do it with a simple elliptical filter, but you have more granularity in control and more finesse to keep that low end tight and to keep it balanced. That's for the case of the stereo whiz. So let's get back to simulate. Also, you see I have a huge chain here, but actually many of the things are automated or turned off. Even some groups are turned on and off. So this is really for momentary appearance of processes. Okay, so we saw about the elliptical filter. If you have a look here, you see now, for example, the width, it's way too wide, right? So this is why I had some width control in my chain. I did control the width, and well, I'm going to show you what was making the problem in this track. I could have said it's just the overall width of the track that is making an issue and just reduce the whole stereo information, but this would have been really silly. Instead, actually, there was some percussion that was playing that was panned super wide, and this is a nifty thing, but I went for Brainworks PanEq, and in fact, if you look, this is 800 Hertz. This range was a range where the root note of the percussion was playing, and this one I focused a lot, like 95%. And by doing that, maybe I can leave the whole chain on and just bypass this one. Yeah, so I'm gonna play this again. So it's printing the audio into Basslane again and without the chain, because this one is bypassed for the moment. You see this range is super wide, right? And if you look at TDR stats now, let's back to this stats, we still have all these issues, right? But what if now I'm turning the Brainworks PanEq back and I'm playing the file again? So now I'm playing it again, and so I'm printing the new information again in the record inside Simulate tool, and so we'll see the impact of this monoing of just that frequency. I believe this is already some interesting approaches. I don't need to reduce the width of the whole mix. There was just one element that was poking and that was making the issues here, and I could pin it down thanks to Simulate. Another thing that's interesting is that I always use multiband like Adapter Metric AB or Vox & Go. This is a free one, and it's showing you correlation per band. And so this is interesting because then you can at the same time look at Simulate and say, okay, I see that, for example, at a certain given time, now it's totally perfect, but I could see at a given time, if I'm playing this track from scratch and I'm looking at the moments where I see on the heat map of Simulate that a problem arises, and then I can go back in move my playhead at that exact time and check what is creating that issue. Is it the overall mix or is it one element? As I said in the intro, I could have, for example, rising up at a drop at the end of a break with white noise, and this is just on the top end at that moment, and so I would just put a high shelf filter on the sides and turn that down until it drops and then bringing it back. And so to avoid applying a process through the whole time and reducing the nice width, the nice depth that you added in the digital master in order for it to comply to the vinyl. Because, well, Simulate shows you that the problem is just at one specific moment. It's not there all the time. We have to check things in different ways. You can see that the Correlometer, is your correlation overall correct or is it overall all over the place? If the general mix is is too much to the minus side, it means that you have too much width, and then you need to tackle that. That will never work. But when you play a track and that you see a problem arises just at a specific frequency, and as you see here, it's the problem is arising in this range, right? And this is because of that percussion. And look at what happens when I turn on the PanEq. Wait, I turn this on like that. Yeah. See, now we have control here. Without, you see it peaking. That's the problem. And that is what making the record skip. As soon as I turn it back on, we are fine. We are fine. We never got across the 0 point, so we don't have anti-phase information in that range. So that's the first very interesting thing, is controlling the width, not all the time, but just on one specific moment. And in fact, the same goes for the Excursion. This is the same tool that you would use, is looking where the problems arise. If you see that it's red all over the place, the whole track, then of course there's too much width. But if the problem arises just at some moments, same for the velocity, this is transitory information on the high end, so you can use multiband compression and just turn it on at some moment, having the threshold very high and then drop the threshold at some moment, or adjust the threshold so that it's never doing anything except in that moment. So yeah, I think this is a much cleaner and a much more transparent way to address things. You don't want to squash the whole track the whole time, and you can just pinpoint the moments where there is a problem and fix it. There are obviously tools inside Simulathe that allows you to do that. You have a general width control, and of course when you turn these, they directly show you what's happening on the record. So this is a nice tool to see it. You can see, for example, how far you could cut things to solve a problem. But in my opinion, if you really want to tackle things in a very refined way, you're better using other tools. And if your CPU can handle it, you can even stay in the digital master project and just adjust some automations from the tools that you already have inserted on your chain. Usually with the tools that I'm using, my CPU doesn't allow me. This is why I'm first printing the whole master without a limiter, and then I'm adjusting this. But for example, if I would see that the whole master is too wide, then I would tackle that in the chain as is. If I see that there's something happening through the whole time, if I have too much low end, of course I have EQs already in my mastering template, and so I can adjust this there to avoid piling up processors for nothing. And this is also why, even if you saw my chain with many things, many of those things are inactive and just turning on for the tracks that I'm using them. So you don't need to cut the lows everywhere on a record. You don't need to cut the width of the informations of the sides in the lows all the time. So from one track to another, you need just some processes from time to time, and this allows over processing. This allows to blurry information, to add noise, to add harmonics, to blurry transients with linear phase filters and this kind of thing. So the take here is be sparse and use Simulathe as a magnifying glass that shows you where you have problems. Look at the tools that allows you to tackle those problems in the most elegant way. For example, the stereo width tool is, I think, an interesting approach. You could mono or reduce the width of everything, but you can also pinpoint what frequency is making that problem. You could roll off the lows of the whole track, or just see maybe in the drop there is a big sub boom with a long extension, and that actually you just roll off that part at that moment. So you leave the sub breathing through the whole mix if it's okay. And this is where it's interesting, because when you look online, you see so many people telling you, oh, if you want to master for vinyl, you need to roll off the lows at 40 Hertz, or you need to cut the stereo information at 120 Hertz. And yeah, okay, if you do all this, chances are that your music will fit on the vinyl. But what is the musical content that you are taking out of it? And especially for club music, we like low-end extension, we like the subs. And if the support allows it, why would you take it out just because someone said it on the internet? So use Simulathe as a magnifying glass to show you what problems there really are in the music, how to fix them, and so you can send pre-mastered version to the cutting plant that is already as much as possible fitting the support, with taking out as little as possible to the music. I hope this was helpful. I hope to see you soon in another video. And if you have any questions about it, feel free to let me know in the comment. If you like the video, hit the little like and subscribe, and see you soon. Take care. Bye-bye.